All right, this lesson right here is actually something that I reviewed. Maddie, haven't even started yet. Put your head down already. Dude, it couldn't be that boring. I just said 2 words. just knocked her out like that. I called you dude, yeah. It's a term of affection. I only call my friends dudes. All right. So, listen. Shh. Listen. In my pre-calc class, you guys listening now? In my pre-calc class, we actually reviewed this for something that they're going to be doing. They're going to be doing some trig in there. You ever hear that? Trigonometry. Yeah. So this is kind of like the precursor. It's like the beginning, the foundational stuff to be able to do some trigonometry. All right. We're not going to do trig in here, but this will kind of set the stage for trig. All right. So it's pretty important. Now, I put special triangles, but we're only going to do one triangle today. On Monday, we'll do the second one. I don't know why I put B right here. Why did I put B? This is A. All right. So this is section 7.4a. So here's the first triangle. Everybody ready? I think this is kind of interesting to see how all this stuff works together. So I'd like you to pay attention and join in on the fun. All right. So the first triangle is a 45, 45, 90 triangle. What kind of triangle is this then? It's a right triangle. Okay. And it's a right triangle because of that 90. Now it also has the other 2 angles. This means these are on degrees. 45 degrees, 45 degrees, 90 degrees. Since 2 of the... Okay, that's true. They do add up to 90. But anytime you have a right triangle, the other 2 angles are going to add up to 90. All right? Doesn't matter what they are. They're always going to add up to 90. But these 2 are the same. So if those 2 angles are the same, tell me something else that you know about the triangle. If 2 angles are the same, that means 2 sides are the same. So if 2 sides are the same, come on, up here. If 2 sides are the same, then what kind of a triangle do we call that? No. You don't just throw geometry words out willy-nilly, as old people say. Isosceles. This would be an isosceles right triangle. All right? So let's draw one. Again, both of these sides, since it's 45, 45, both of these sides need to be exactly the same. That looks a little bit longer, doesn't it? What?
Which one do you like better, geometry or football?
What?
Obviously, geometry. Obviously, freaking geometry, dude.
Like the Eagles or geometry?
No.
It's a valid question.
Dude, obviously, geometry.
Obviously, Josiah. Obviously. All right, here we go. So this is 45. All right, no more silly questions. All right, here we go. What do I call this side right here? It's got a special name for it. It's the hypotenuse. Okay, I'll just put HYP. Is that all right? What do I call these 2? Now, if this is 45 and this is 45, that means these 2 angles are equal to each other, which means the opposite sides are equal to each other as well. All right? So these 2 sides are equal to each other, and I call these the legs. So both legs are exactly the same. So if I told you that this side was 5 and it was a 45, 45, 90 triangle, and I did not tell you this leg right here, what could you automatically say about it? It's also what? It's also 5. All right? Because 45, 45 means that these 2 sides are equal to each other. If it's a 45, 45, yes. Okay? Only if it's 45, 45. If it's 44, 46, they're not equal to each other.
What if it's a 35, 35?
Then there is no 35, 35, 90. Because that would be 70 plus 90, which would be 160. Right? All triangles add up to 180. So this is 45 and 45, which is 90, plus this 90, that's 180. So you can't have a 35, 35, 90 triangle. Everybody got that? Is somebody trying to come in? Nate, can you get the door? Yeah. Put your headphones on my desk first. Come on. That's why you weren't listening. Is that why your hair is that long, so it covers up your earbuds? All right, so let's do this. All right, that's enough of that. Let's do this. Nate, put your earbuds on my desk. What if I made both of these, what if I made this side 1? And I asked you to find the other two sides. First of all, what's the easiest one to find? Yes, this would be 1. That's correct. Now, how do I find this side right here? Not what the answer is, but just how do I find it? What do I use? I use some method. Give me a name. There's a name for this. We just went over the worksheet on this. Thank you. It's the Pythagorean theorem. All right, what's the Pythagorean theorem?
A plus B plus C.
A squared plus B squared equals C squared. Okay? So look, what are my A and B? They're both 1, aren't they? So that's 1 squared plus 1 squared equals, we don't know this, I'll call it C, and equals C squared. All right? 1 squared is 1, plus 1 squared is 1. So if your parents ask you today, what'd you learn in math class today? What are you going to tell them? I learned how to do 1 plus 1. All right? So 1 plus 1 is what? 2 equals C squared. Where are you going? Did you ask me? Anybody else hasn't gone to the bathroom yet? I guess my class is the one. So watch. Square root, square root. What happens here? Square root and square cancels. So what's C equal to?
C equals the square root of 2.
You got it. Square root of 2. So I'm going to put that right here. All right? So that was nice. Wasn't that exciting? But watch this next thing. This next thing is kind of cool, I think. I don't know. What if I didn't make this 1? What if I made it, let's say 5. Made it 5 earlier. Make it 5 again. Okay? Now, if the two sides were 1, what was the hypotenuse? The square root of 2. Right? If the two sides are 1, then the hypotenuse is the square root of 2. Agreed? Yeah. What if both sides were 5? Well, let's do the math again. So what would I do? Let's do it right here. 5 squared plus 5 squared equals C squared, right? That is 25, and that's 25. What do you get? You get 50. What's that? C squared. Square root both sides. Now we got to simplify the square root of 50. We've talked about this before. Let's do it again. Pick a couple numbers that multiply to be 50, and hopefully one of those numbers you can take the square root of. So 5 times 10 is probably not a good choice. Yeah, why is 5 times 10 not the greatest choice? Because you can't simplify square root of 5, you can't simplify square root of 10. Now, I could do something else to simplify further, but for right now, let's just say 25 times 2. That's a good thing to use. Why is that good? Because I could take the square root of 25, right? So let's break this down. We talked about this the other day. I can take this one big square root and break it down into 2 smaller ones. Okay, that's an algebra topic that we talked about just the other day. What's the square root of 25? It's 5. Square root of 2, you can't do anything with it. You just leave it, square root of 2. All right, let's go back to red. So if this is 5 and this is 5, what's the hypotenuse? 5, what? Square root of 2. So check this out. If both of the sides were 1, then the hypotenuse is 1 times the square root of 2. You guys listening? Come on, pay attention. It's not that hard. Maddie, snap out of it. Look up here. Pay attention. You're not paying attention. You're looking over here in a corner. I don't know what you're looking at. Look up here. Okay. You don't have to look at me. I can understand why you wouldn't want to look at me, but look at the screen. All right? Just look at the screen. All right. Everybody look. Now look. I'm on the verge of this great discovery, and you guys aren't on board. All right? So look, I'm serious. I'm dead serious. When both of the sides were 1, what was the hypotenuse? 1 times the square root of 2. When both of the sides were 5, what is the hypotenuse? 5 times the square root of 2. So let's take a wild guess. Let's make it a 7. What if both sides were 7? You got it. It's 7 times the square root of 2. Okay? Whatever. Yes, that's what I want to hear. All right? Both of those sides are the same. How do I find the square? How do I find the hypotenuse? I just take the leg, right, and multiply it by the square root of 2. So I got a formula that we kind of came up with together. I helped you a little bit. but you kind of saw what was going on, right? So what's the hypotenuse equal to then? It's equal to the square root of 2 times
The leg.
the leg. Very good. And that is a super important formula, we'll call it, all right, for a 45, 45, 90 triangle. Again, this only works. This only works when it's a 45, 45, 90. You got it? So the hypotenuse is always the square root of 2 times one of the legs. Let's do an example. It's kind of the example we just finished doing, but let's do it anyway. It's still a right triangle, but they are... just looks a little different. It's just drawn kind of crooked. All right. This is 45 degrees. This is 45 degrees. And they tell you that that is 3. And they ask you to solve for B and solve for C. They're both pretty easy. They're both of these things you could actually do in your head without even writing anything down. So find B. What's B equal to?
45.
Come on. B is a side. It's the length of a side. Come on. Think before you speak. It's 3. Right. So I know you knew it. You just got to think before you say stuff, okay? So if this is 3, what's this? It's 3. Now, it's only 3 because you got a 45 and a 45 there, okay? If that was something else, if it was 40 and 50, they would not be the same, okay? They're only the same because these two angles are the same. So if that was 3, that's 3. That was super easy, wasn't it? B equals 3. C is just about as easy, except you just have to know that. If you know this, then finding C is super easy. C is the hypotenuse, right? How do I find the hypotenuse? What do I do? You got it. You just write 3 times the square root of 2. And that's that.
That's the hypotenuse.
That's the hypotenuse right there. It's 3 times the square root of 2. It's not too bad, is it? All right. Now, this is a little bit, it's not, I wouldn't say it's difficult, but I would say it's more difficult than what we just did. All right. So I won't pull any punches here. Let's move this over. Just give myself some more room. Watch this. It's the same kind of problem. Let's scooch that. Do they look the same length? Yeah, pretty close. This one looks, that one's a little bit longer, doesn't it? Maybe about right there. Close enough. Good enough. All right. And so I'm told that that's a right angle. I'm told that's 45 degrees. I'm told that this is 45 degrees. What if they didn't tell you the angles? What if they just told you that this side was equal to this side? What could you say about the angles?
They wouldn't be 45.
No, if
It's equal.
it's the other way. If these two sides were given to you to be equal, what could I say about this angle and this angle? They're both 45. Okay? All right, that's all I'm trying to show you. Because they don't always tell you it's 45. They might tell you that this is, what number do they give you?
Number not there. Right?
Right, let's say if they said that this was 5 and this was 5, then you know it's 45, 45, correct? Okay. This time, they tell you the hypotenuse. They don't tell you the legs. So you got to find the legs. I could call it A and B, but both of the legs are exactly the same, right? So let's just call it X. Is that all right? So this is X and that's X. How do I know they're both exactly the same? Because I've got 45, 45, 90 triangle, okay? Now, listen to me carefully. If you know the leg, how do you find the hypotenuse? You multiply it by the square root of 2, okay? If you know the leg. What if you knew the hypotenuse? How do you find the leg? You divide it by the square root of 2. Everybody see that? So pretend, we'll get to this one in a second. Pretend on this problem you didn't know either one of these, but you did know the hypotenuse, all right? So I could take the hypotenuse and do what to it to find the leg? Go the opposite way. Instead of multiplying, we divide. Everybody see that? And what happens to the square root of 2's? They cancel. So what is this? That's 3. See how it works out? Now this one's a little more complicated. The first step's not complicated, but simplifying the square root's a little complicated. And I want you to pay attention. I want you to learn how to do this. This is something that you probably were not taught in Algebra 1, but that's what I'm here for, okay? I'm here to catch you up, right? And to get, I'm here to make sure you know some of that basic algebra stuff that you didn't learn in algebra, even though this is geometry class. So let's figure out what's going on here. They give you the hypotenuse. Let's use this formula right here. Watch. Hypotenuse equals what? Square root of 2 times one of the legs. Everybody see that? This one, what do they tell you? They tell you the hypotenuse. So what am I going to put in place for that? A 12 equals, put a square root of 2 right here, times the leg. What's the leg? Don't know. And what did I call it? I called it x. You can call it any letter that you wanted to, but I'm going to call it x. So now what we're going to do is we're going to solve for x. Just like we said before, if I know the leg, how do I find the hypotenuse? I divide by the square root of 2. So what do I do here? Divide by the square root of 2. See how it works out that way? This cancels. What's x equal to? 12, what? Divided by the square root of 2. You're like, okay, that's not that hard. Why did you say this was harder than the other one? Well, for this one reason. Do you see how the square root is in the denominator? If you did not learn this in Algebra 1, this is probably the first time you've ever heard this. But in math, somebody came up with this. It's probably more than one person. But somebody came up with the fact that you cannot have a square root in the denominator. There's reasons for it. We're not going to get into it. I don't even know if I could really give you a good presentation on why. But I've seen some stuff on YouTube. I talked to Mr. Rao last year. Why can't you have a square root? I've always known that, right, ever since high school. They always told me you can't have a square root in the denominator. Nobody explained it to me. And I'm not explaining it to you now. You could always look it up on YouTube. But just know that you're not allowed to have a square root in the denominator. And we do. So what am I going to do? How am I going to get rid of that square root in the denominator? Well, I'm glad you asked. So here's what you're going to do. Let's use the square root of 2. All right? How in the world would I get rid of that? Well, watch. Okay, you could square it, but I'm not going to square the bottom and square the top. That will not work algebraically. But watch what I'm going to do. Watch what I'm going to do. What if I multiplied it by itself? That's the same thing as squaring it, isn't it? All right, so what is the square root of 2 times the square root of 2? Square root of 4. What is the square root of 4? It's a 2. So check this out. Watch. How did I start with a square root and end up with a whole number? What did I do to it? I multiplied it by itself. Okay? And that'll get rid of your square root. So if I have a square root of anything, if I look, let's pick some crazy number, like the square root of 77, okay? If I had the square root of 77, how could I turn that into just a plain old regular 77? I would go the square root of 77, what? Times itself, okay? And when I multiply it by itself, what's it going to do? It's going to get rid of that square root and just leave the number, all right? So I would have just a 77. So check this out. Watch. How do I get rid of that square root of 2? I multiply it by a square root of 2. But I got to do something to the top as well. I also have to multiply the top by the square root of 2. Because I can't just, out of the blue, just multiply a number by the square root of 2. But I can do this. Josiah, watch. This is interesting. Watch. What is the square root of 2 over the square root of 2? No. What is any number divided by itself? What's 5 divided by 5? It's not the same thing. It's 1. What's 7 over 7? It's 1. What's 100 over 100? It's 1. What's 1,000,000 over 1,000,000? It's 1. What's the square root of 2? Shh, I'm on a roll here. Don't interrupt me. What's the square root of 2 over the square root of 2? It's a 1. Am I allowed to multiply any number by 1? Yeah. Why? Doesn't change it. It stays the same. Exactly. Okay? So am I allowed to multiply this by a 1? Yeah, it doesn't change the value at all. All right? But what it does, why did I do that? Why did I go through all this mess? Because it gets rid of my square root. Because what's the square root of 2 times the square root of 2? It's 2. There you go. Now I don't have a square root in the denominator. Okay? Math teachers don't like you having square roots in the denominator. And we got rid of it. But what's the top going to be, though? 12 what?
12 square root of 2.
You got it. 12 square root of 2. Do I circle that? Am I done? I got one little simple step I got to do yet. What is that?
Simplify.
Okay, and how do I do that?
I don't know.
Look, I got a 2 on the bottom and a 12 on the top. Yeah, 2 goes into 2 once. 2 goes into 12 6 times. So what's my final answer then? 6, not over, 6 times the square root of 2. And that's what this is right there. It's 6 square root of 2. And this is the same thing, isn't it? And that's my answer. That's how I find the legs, if I'm given the hypotenuse. You see that?
That was all right.
Yeah, it wasn't too bad, was it? I had to go back and teach you some stuff about this. We give this a name, this thing right here, this whole process. Might as well say it now. We call it rationalizing the denominator. All right? So, when you take Algebra 2 next year, they're going to talk about rationalizing the denominator at some point. Okay? That's what this is. And then hopefully, you're going to tell your teacher, whoever it is, that, oh yeah, we did that in geometry last year with Mr. Hamrick. I remember learning about rationalizing the denominator. All right? So you'll be a step ahead of everybody. All right? There you go. Make sense? All right. That's all I'm going to... Well, let's do this. I just want to show you this. A lot of people think that when they give you the whole number, it makes it a little easier. Actually, when they give you the hypotenuse as a whole number, it makes it a little bit more difficult because I got to go through all this stuff. Okay? A lot of people will look at a problem like this. We've already done it once. Let's just do it again. A lot of people would look at a problem like this and say, oh man, that's really tough because they gave you 3 square root of 2, right? Because a lot of people, when you're first learning square roots, you really don't want to deal with them, all right? After a while, you get used to them and they're not that big of a deal. But what if they give you this as 3 square root of 2? How do I find the leg? I divide by the square root of 2. I've already done it once right here. Let's do it again. 3 square root of 2. How do I get this right here? I just divide it by what? The square root of 2, and then that cancels. See how nice that is? When they write that with a square root of 2? So I'm just left with what? A 3. This one, it's a little bit more confusing because you got to go 12 divided by square root of 2, and then you got to do the whole thing where you got to, that's it. You got to rationalize the denominator, correct. But after you get used to that, it's really not that hard. But it's a skill that we use a lot. In my pre-calc class, we're doing that now, okay? I mean, we do it a lot through the year, but we do that quite a bit. This is a skill that we use quite a bit, all right? So it's not like it's a one-shot thing. You learn it one time and you never see it again. You will see it again, all right? So make sure that you get a good idea of how to do that. We good with this? All right. Now, I split this up into A and B because the B part, so the first one is a 45-45 90 triangle. And the next one is this. It's a 30. What do you think if it ends in 90? What do you think this one is?
120.
Look, these two have to add up to be 90. 30 and 120, does that add up to be 90?
I thought you added them.
No, look, 45 and 45 add up to be 90. So this one and this one, you're right, it's a 30, 60, 90 triangle. Okay? So what does that look like? It doesn't have equal sides. One side is longer than the other. You see that? So that's what we're going to do on Monday. Sneak preview. Bet you can't wait till Monday then, right?
Yeah. It's like after the movie's done.
You're like, really? Do I have to have a weekend? I wish I could just learn about 30, 60, 90 track.
Weekend.
I love geometry.
I'm kidding, of course. Okay, so that's what we're going to do on Monday. You do have a homework. And yes, you do. Yes, you do.
I love geometry.
Don't you always have homework?
Get out.
Should be used to it by now, right?
Mr. Henry,
What?
I love geometry.
Okay, good. Oh, you know what? Oh, man. No, you do have homework, but why did I do that? You know what I don't know what I was doing. Oh, my word. The other class, I told them to do way more problems than you need to do. So, I don't know. If you see, you guys have class together, right? Tell the other ones. All right, here it is. It's on RenWeb anyway, so they should be able to look at it and see. So it's section 7.4a, and you're not doing that many, all right? So try to get these done. What is it? 1, 2, 3, 7, and 8. 1, 2, 3, 7, and 8. I forget what I told them. I told them to do like 15 problems. All right, so tell the other class, all right? You promise? Somebody do that? Yes, tell the other class. 1, 2, 3, 7, and 8. Yes, that's it. All right. Have a good weekend. Enjoy your homework. And I'll see you on Monday. Go to the play tonight. Right, Autumn? How did it go last night? Was it good? It went? It wasn't?
it was better than last year's.
Oh, was it? Okay. I'm coming tonight to take pictures, so make sure it's good tonight, okay?